In this lesson, we're going to be talking about logarithms. Now, first off, what is a logarithm? A logarithm is another way of writing an exponent. This is a logarithmic form right here. We read this as log base b, whatever number's down here, and that's actually a subscript. That's a little bit lower than where log is written. I write it as log, and then the b would be down here somewhere. Okay, so this is log base b of a is equal to x. To change that to an exponential form, because this is, again, just another way of writing an exponent. It's b, the same base here is the base of your exponent. B to the x power is equal to the argument a. So that's how we change from logarithmic form to an exponential form. Common log is a logarithm with a base 10. Now notice what we can do here. A logarithm with a base 10 is called a common log. You can write it without the base. So log base 10 of x, we can just write as log of x. So if there's no number in the base, it's understood to be a base 10. So now let's convert between forms. It says write each of these in exponential form. Log base 7 of 49 is equal to 2. We're going to write this as 7 to the second power is equal to the argument 49. That's it. The next one, the base raised to the number over here, 2 to the fifth power is equal to 32 is how we rewrite this. Next one, log of 1,000 equals 3. Now, if there's no number, again, that's called a common log. The base is 10. This would be 10 to the third power is equal to 1,000 is how we rewrite this. The base here is 4. 4 raised to this power. Let me zoom in a little bit. 4 raised to the power of negative 3 is equal to the argument 1/64. Number 5, the base raised to this power, or 8 to the 1/3 power, is equal to the argument 2. And again, if you don't remember, that's actually the cube root of 8, which does equal 2. And the next, number 6, 9 is the base of your logarithm. It's also going to be the base of your exponent. Raised to this power is equal to 27. And just as a reminder, that would be the square root of 9 to the third, which does equal 27. Now let's do it the other direction. Write each equation in logarithmic form. So we're in exponential form here, so now let's write in logarithmic. The base of your exponent is also the base of your log. So we're going to do log base 5 of 25. So log base this of the number on the other side is equal to the exponent. The exponent's over here by itself. So you can go backwards and forwards. 5 to the second is 25 is how you'd rewrite that. This will be log base 8 of 1 is equal to. Now, think about this as we're writing it down. 8 to, or any number to the 0 power is 1. So whether it be log base 8 of 1, log base 9 of 1, log base 1,000,000 of 1, that would always equal 0 because any number to the 0 power is what's equal to 1. The next one, log base 3, and that's the biggest thing is remember the base of your exponent and base of logarithm is the same, of the number on the other side of the equal sign is equal to the exponent. So log base 3 of 1 over 81 is -4. Log base 12 of the value on the other side of the equal sign, 2 root 3, is equal to the exponent, 1/2. Number 11, log base 10. Now, if it's a common log, again, you don't have to put that base. Log base 10 of 1/10 is equal to the exponent, -1. And number 12, last one of these, log base 16, which is the base of your exponent, of the value on the other side is equal to 3/4. Again, 16 to the 3/4 is 8 is how you would rewrite that. Now, as it says on the next part, evaluating logs, evaluate the following logarithm using your knowledge of logs. So what we're going to do here, if you need to rewrite it, you could put, before we start, you could put out here equals x. So that you can say, okay, now 6, if I rewrote that, that'd be 6 to the x power is 36. Then you can see what it's equal to. Or you can get to a habit of, to evaluate this, you're saying 6 raised to what power is equal to the argument. So that'd be 6 to the second power is 36. 2 to what power is equal to 128. 2 to the first is 2. To the second is 4. I'm going to count through these. 2, 4, 8, 16, 32, 64, 128. That's 2 to the 7th power is equal to 128. Number 15, doing the same thing. The base here is 10, so we're saying 10 to what power is equal to 1 over 100. Well, I know 10 to the second is equal to 100, but we need that 10 on bottom. So therefore, what we're going to do is we're going to raise it to the negative 2 power. Again, a number raised to a negative exponent moves that value across the fraction bar. Next one is 16 to what power is equal to 2. Now, this one's a little bit tricky. Because we're now actually doing square roots, cube roots, fourth roots, fifth roots. We're doing roots here. And I know the square root of 16 is 4, and I know the square root of that would be 2. So you can work it backwards and say 2 to what power is 16? And I know 2 to the 4th power is 16. So that means 16 to the 1/4 power would be 2. So therefore, the 4th root of 16 is 2, or 16 to the 1/4 power is equal to 2. This one again, 3 to what power? We're going to have to bring that 3 to the bottom. So therefore, I know my power is going to be a negative, and I know that 3 to the 3rd power is positive 27. So therefore, 3 to the negative 3 power would be 1 over 27. And finally, I think I told you a while ago, we've already worked this once, 8 or any number raised to the 0 power. That's the only way that you're going to get a 1. And next up, our change of base formula. Says this: some logarithms are not as easy to evaluate as those above. Those are pretty easy and will require a change of base formula. Now, here's what our change of base formula says. That a log base b of a. Now, our calculators know two different types of logarithms. They know a common log, which we've already discussed, and then a natural log, which we'll discuss later. So let me show you how we can change a logarithm to any base we want to. And in this case, I'm going to change it to a base 10. Why? Because my calculator knows it. And that's what it says here. Choose base 10 because there is a calculator button for it. So log base b of a can be typed into your calculator by doing the log of a divided by the log of the base. The log of the argument divided by the log of the base. And when you rewrite this, the base here can be anything you want it to be. In this case, what I change it to? 10, because that's what my calculator knows. So here's how we're going to do this. Log base 5 of 34 is saying 5 to what power is 34? Now, I don't know that. I know it's 5 to the second is 25, 5 to the third is 125, so that's too big. So it's somewhere between 2 and 3, but how do I find it? Change the base formula says this. Log base 5 of 34 can be typed into your calculator by doing the log of 34 divided by the log of 5. Again, I changed both of those to base 10s. I could have changed them to base 7, base 8. I could change it to any base. I could put any number down here I want to. But again, I chose 10 because that's what my calculator knows. And log of 34 divided by log of 5, when you type into your calculator, make sure you close these parentheses or you'll get the wrong answer. You're going to get about 2.1911, so a little over the second power, which is what we said. Now, 2 to what power is 98 is what we're working here. The way we're going to find that out is the log of 98. Make sure you close your parentheses on your calculator, divided by the log of the base. When we type that in, and I'm going to put my approximate symbol, we're going to get about 6.6147. So 2 to nearly the 7th power is equal to about 98. Next one, 20 to what power is 4? Now, I know this is going to be a fraction, value smaller than 1, because I know 20 to the first would be 20, so it's going to be between 0 and 1. The way we type it in is the log of my argument divided by the log of my base. The log of 4 divided by the log of 20, which is going to be about 0.4628. Number 22, log base 6 is 2. 6 to what power is 2? You're going to type it in as the log of 2 divided by the log of 6. And that's going to be about 0.3869. And again, notice it's less than 1 because 6 to the first is 6. That's too big, so we know it's got to be smaller than 1. And we knew that 6 to the 0 power is 1, so that's going to be too small. 3 to what power is 225? We're going to do the log of 225 divided by the log of 3, and you get about 4.9299. And notice how close that is to 5. 3 to the 5th power, I believe, is 243. So that's just barely too big. So that's the reason you got a value nearly equal to 5 there. 8 to what power is 1/2? We type in as the log of 1/2, which you can put 0.5 there if you'd like, divided by the log of 8. And that's going to equal about, actually this one's exact, and it's equal to negative 1/3, or negative 0.3 repeating, you can put. And the reason for that, and I didn't notice it, hey, we can do 8 to the 1/3 power and gives us 2. So therefore, if you raise 8 to the negative 1/3 power, that would give you that 1/2 that we needed. Okay, next up, the other logarithm that your calculator knows, a logarithm with a base of e. And a reminder that the e value is 2.71828 ... It's an irrational number. When you have a base of e, it's called a natural log. But we don't write it as log base e like this. We write it as ln of x. That's the abbreviation or the notation that we use for the log base e. And it is so common that we do have a notation for it, and your calculator does have a button for it. You can find that. And that same change of base formula would actually work for it as well. It says write each equation in exponential form. So let's change these now. This would be log base e. Let me zoom in. Log base e of x is equal to 4, so therefore we could rewrite that as the base raised to the value on the other side is equal to the argument. That'd be e to the 4th power is x. The next one, natural log of 10 is equal to x. That'd be natural log would be log base e of 10 is equal to the x. I like to put the e down there when I'm rewriting it. That'd be e to this power, e to the x power is equal to the argument 10. Now let's change to the other direction. Write each equation or write exponential into logarithmic form. This would be a log base e of the number on the other side is equal to x. But again, we don't like putting log base e. We put the natural log instead. So ln of 50 is equal to x. This would be log base e. And let's not write log base e. Let's put ln of the value on the other side is equal to the exponent. Natural log of x equals 0.5. Okay, now approximate each value of each expression. Simply use the ln button on your calculator to evaluate these. All you're doing here is you're hitting the ln button on your calculator and typing in 64. The ln of 64, now that will be irrational. So let me do approximate. The ln of 64 is about 4.1589. And then number 30, the ln of 1/3, again, you're just simply typing that into your calculator. That is an approximate value. It's equal to somewhere around negative 1.0986. Now, let me go back to just one problem just to show you something on that change of base formula that we've been working up here, maybe number 22. Just for kicks, just to show you that this change of base formula always also works for a natural log. If you'd like to change these to a log base e, you could do log base e of 2 over log base e of 6. And when you type that in, you would get actually the exact same answer. So you don't have to change it to a log base 10. You could actually also change it to a log base e and get the exact same answer.